Hey everyone, this is Zoe from Seneca, and today we're going to talk about ionic Lewis structures. Lewis. Dot and cross diagrams can show electrons being transferred and ions being formed. Dots represent electrons from one atom and crosses represent electrons from the other atom. Square brackets and a charge, for example 2+, represent ions. The calcium atom transfers its two outer electrons to the oxygen atom, creating Ca2+ and O2- ions, which both have full outer shells, which is what you like. The sodium atom transfers its outer electron to the fluorine atom, creating Na+ and F-. Both of these ions have full outer shells. Barium is in group 2 and chlorine is in group 7. In the dot and cross diagram for barium chloride, there would be one barium ion and two chloride ions. What can we show using dot and cross diagrams? Number 1, the transfer of electrons. Number 2, the ions formed. So they're pretty important. If you're just listening to this, then definitely search up some photos and examples and have a look on our website to see how they're made. Okay, so ionic compounds form when millions of metal atoms transfer their outer electrons to millions of non-metal atoms at the same time. The resulting oppositely charged ions are held together in ionic lattices. Ionic lattices are giant structures that are held together by strong electrostatic forces between oppositely charged ions. And then electrostatic forces are the electrostatic forces are called ionic bonds, and they extend in all directions within the lattice. Ionic lattices are giant structures formed by ionic compounds. Okay, in order for the charges to balance out when the overall formula to be neutral, so that the overall formula can be neutral, there must be, in this example of Ca2+ and F-, two F- ions for each Ca2+ ions. So the empirical formula is CaF2. Now with sodium and SO4 sulfate ion, and we have Na+ ion, in order for the charges to balance out and for the overall formula to be neutral, there must be two Na+ ions for each SO4 ions to balance it out. Therefore, the empirical formula is going to be Na2SO4. Okay. The calcium ion, so this is the dot and cross diagram for calcium and oxygen. The calcium atom transfers its two outer electrons to the oxygen atom, creating Ca2+ and O2- ions, which both have full outer shells. Okay, what is the empirical formula of sodium oxide? So, step 1, we need to establish what ions are formed by each component of the ionic compound. So the Na atom goes to Na+ ion, and the O atom goes to O2- ion. You can just look at what groups they're in. Step 2, we need to calculate the simplest ratio of these two ions that will result in a net charge of 0. So, Na+ and O2-, the ratio needs to be 2 to 1. 2 Na+ to every 1 O2-. We then convert this ratio into a formula and we end up with Na2O. Okay, simple as that. Thanks very much for joining and we'll see you on the next episode.